Okay. One moment, I close my Twitch. Okay, nice. Okay, now I think I will take a few parents here. The first that is always. We have priority with the left child, yeah, and in this case I need to move until reach the leaf, yeah, and in this moment come back to the previous, or even have this, and for example the parent of this is null, yeah, and in this case move to the next and set the parent of this number, the parent is 1, yeah, and for the next that is the same, the parent of the 4 is 2, yeah, in this case is the same, and in this case is the same, in this case is null, yeah, it's only for have the reference with the parent. Now the next that is, okay, I am here, now is move until reach the leaf, the first leaf, no, in general the leaves. Now I am in the 4, but I have the reference to the parent. Okay, now I need to have or create the reference to this, in this case the 4, the right child now is the 2, now we have this reference, and the 2 I need put this reference, you know, in this case it should be parent dot left it's equal null, yeah, and I put this, and now the parent, no, current node it's equal that parent dot right is th, right? In this case the parent is this, the right is this, and is the current node dot left, yeah, this case current node left it's equal 5, and I need set parent dot right it's equal null. Now we have this structure, and if I continue with this model, this is still with the reference as a left child of the 1, and we have this is now if I apply this, I need go to the right, you know, because the right child in the previous state was as a root. In this case, this these two have the reference to the previous. Yeah, in this case, go to the right child. In this case, we are in the 2 here, and now here I have the reference to the parent. In this case, I reference to the parent that is 1, means that the 2 now is the parent. The first is okay, I go to the parent. No, this is the new root, and go to the parent. The parent, in this case, current dot left, it's equal parent dot right. Yeah, and next to is parent dot right. The parent is 1. It's equal null, means that this is cut, and here is the current dot right, it's equal root, and now we have this 3 1, and this disappeared because was updated. 4 5 2 3 and 1. Okay, but this works because it's a short hey Solaris, the problem is this, yeah, is basically alterate the tree, and this is the rules. The original left child become a new root, the original root becomes the new right child, and the right child becomes a new left child. Yeah, for example, this, and the final, this is the new root. The root is the new right child, and the right child is now the new left child. Yeah, and the logic with this is that try to go to the final of the elements. In this case, for example, I need, or I want to add 1 element here. There's 1, there's 2. Yeah, and the idea behind my logic is that have the reference of the parent. You know, in this case, even I think that I can use a hash map for handle this reference, but well, only for visual use. Here is basically the parent of the 1 is null. The parent of the 2 is 1, the parent of the 4 is 2, the parent of the less 1 is 4, 4, 1, no, 1, 2, and 1, okay? Now the idea is, my idea is start here, go to the left, always go to the left. Now I am here, yeah, and now in this moment, I am here, and get the parent. In this case, the parent is 4, and apply this transformation. The first that is, I think that before to do this, is that go in this side, the parent is 4, and set the current dot right, it's equal to the parent. Yeah, in this case the parent is the number 4. Okay, now the next that is the current dot left, it's equal parent. Yeah, in this case parent dot left, no, right, sorry, right. In this case the parent is this, the right is less 2, is less 2. Okay, less 2. Okay, and in this moment, for example, we have the reference. I need to cut the reference because we can create cycles in this. This is connected with this and with this. You know, in this moment we have a cycle. Now we need to cut parent dot left it's equal null, and parent dot right it's equal null. In this moment this disappear and this disappear, and now we have the new structure, the one with the 4 and the one with the less 2. Yeah, and now is I was in the less 1 is here. The parent of the less 1 is the 4. If I go to the 4, and I think that here I need to update it and set the parent of the 1 change to 2. If I updated the parent of the less 1 is def the 4, now is 2. I can say that the 2, sorry, less 1 is a new parent. The 2 should be as a right child, means that I need transversal this until it reach the left and set okay. The 4 in the right side is 2, and the 2 is transformed, no, the 5 is transformed as a new left child. And if I draw the connection here, come on, the connection here is that less 1, no, sorry, 4 now is connected with the 5 and is connected with the 2, and I need disappear this and this. That is exactly this, the parent. Disappear this. But I noticed that I always need to do 2 things. The first, that is always try to reach the final, in this case the left, yeah, here, and the other is that is in the right direction always. And I need to update the parent. For example, in this moment at the beginning, the parent of the 2 or the 4 is 2, but when I update it, now the parent of the 2 is 4. Okay, sorry. Hey, yourself. Okay, I think that I have the key for this problem. The problem is this: change the tree with these rules. The left child is the new root, the right child is the left child, and the original right child becomes left child. Yeah, this is the rules. Transforming this to this. And I am doing this using the parents as a reference, but I think that maybe it's not necessary. Okay, if I only handle this and I go to the final, maybe I can stop before to continue with the next, stop here and apply the operation. In this case, I am here in the 2, okay, and said parent dot left dot right it's equal to, yeah, in essential I am creating the connection between this. And now the parent dot left is try to transversal until the final, you know, yeah, until the final of the this3, in this case is here, and is parent dot left dot right, no, parent dot left, in this case is this, it's equal to parent dot right. In this case we have this connection with this, but now we have a cycle. We need to cut this connection, and if I was here, no, I think that it's necessary to have the reference with the parent, because in other way, how can I come back to the previous? Yeah, I think that my approach to use the parent as a parameter, in this case the parent of the 2 is 1, the parent of the 2 is the parent of the 4 and 5 is 2, and this is 1, and this is null. And reach this position, the deepest node, that is this, and now is set that current node, that is 4, dot parent, that in this case is 1, no, is current node dot left, it's equal current node dot left, it's equal, and here I need execute a while and set that parent dot right let me check, because here's mentioned every right node in the tree has a sibling, a left node that share the same parent. Every right node in the tree has no children. Okay, no, in this case it's not necessary do this, because here mentioned that doesn't exist, it's only the right. In this case is parent dot right, now this 4 in the left in the left, oh yeah, got it, here is different. Here is a current node, it's equal 4. I need apply a while and try to figure out what is the final of this element. In this case I am in the last, but well, I need to replicate for other nodes. In this case is 4, and is basically go to the deepest node in the left child. In this case is current node, it's equal current node dot left, and yeah, in this case reach the final. In this case the final is null, and now is current node dot left, it's equal to parent, that is this, parent dot right, yeah, in this case this 4, in the left it's equal 5, that is this. Okay, got it. Now the next dot is for the right is current node dot right, it's equal parent. And now is parent, exactly this, parent dot left and parent dot right. Parent dot left and right, this and this connection are disable, are eliminate. But now I am here. Now I think that I need to go to the right. When I apply this, the next move is current node, it's equal current node dot right, because the right was as a root or previous root. In this case is this number 2. Okay, now this number 2 have the reference to the 1. Yeah, in this case we have the 2 have the reference to the 1. Now, this is the parent, the 1. And now is apply the same current node, that is 2. I need to go to the final of the this 2, in this case is here and is current node dot left here, it's equal parent, that is 1 right. Okay, now and now current node, that is 2 dot right, it's equal the parent, that is 1. In the parent put the connection here. Now for example for this we have the 3 and we have the 1. Now I'm here. Now I need to go to the right. In this case the right is 1. Now for the 1, well, in this case is null. Current node dot left, it's equal parent, well, in this case is null and null. Well, I think that it's right, this approach, because we have 4, 5, 2, 3 and 1. Okay, but well, I think that it's enough for this session, because I need to do a few things today. But thanks for following this transmission, and I hope see you in the next. Bye bye.